Hello everyone. In today's lecture, we are going to learn about addition of vector. Means if two vector is acting at a point, then how to calculate resultant of both vector. So this addition of two vector is also known as resultant of two vector. Okay. So this topic is addition of two vector. This is also known as resultant of two vector. Okay, so resultant of two vector. Why it is required to find out resultant of two vector? Let's think about there is a body. There is a body. Okay, on this body you are applying two force in two direction. So let's take this is force F1, this is force F2. So you are applying two force on this body. Okay, acting at an angle. Let's take theta. So can you say that in which direction this body will move? You cannot say simply that in which direction body will move. Let's say F2 greater. So F2 greater than F1. Then also we cannot say that it will move towards F2 direction only. If there is only F2, then it will move towards F1, F2. If there is only F1, then it will move towards F1. But if both force is acting, then we cannot say that it will move towards F2 or F1 until unless we find out resultant. So resultant means we will replace both one with a single vector. That single vector will be resultant vector and this body will move in resultant direction. Whatever will be direction of resultant vector, in that direction only this body will move. So let's take here, this is resultant direction and this is resultant value. So we can replace here both forces by a single force, that is R. So this body will move with that much magnitude in that direction. Means whatever is direction of this resultant, in that direction this body will move, and whatever is resultant value, with that much force it will move in that direction. Okay, so this is how. So here we have to replace two vector with a single one. That single one is nothing but resultant vector. Okay, so this is what we are going to find out, resultant vector and direction of that resultant vector. Okay, so here which kind of vector we will add? So point, we will always add here, means we can always add here, always similar physical quantity are added. Similar physical quantity are added means we cannot add here force and acceleration, force or velocity, or acceleration with velocity. Always similar quantity, similar physical quantity will be added here. Okay. Second point, it's not like a simple algebra addition. Okay. Here resultant of two vector, that means if we add two vector, we will not follow simple method to add two vector. Simple method means 2 plus 2 equal to 4, 2 plus 3 equal to 5, like that. So here it is not simply added like algebra, like simple algebra. Okay, so here we will follow vector algebra. Okay, so here we follow vector algebra to add vector. Okay, or to find out resultant of two vector. Okay, so here there are two laws. In two laws, one is trigonometric, that is triangle law of vector addition, and second one is uh, parallelogram law of vector addition. Okay, so there are two laws. First one is triangle law of vector addition. Triangle law of vector addition. So we will define first what is triangle of vector addition. Okay. So imagine that there are two vector A and B. Here I will take vector A and B. So let's take here, this is a point or this is a body on which two vector is acting. This is vector A acting, this is vector B acting. Vector A and B is acting at an angle theta. Okay, so here how will I find out resultant of this A and B? So here by using triangle law, we will construct a triangle. So here draw a triangle, draw a triangle, triangle using using draw a triangle using vector A and vector B as a side of triangle in such a way that in such a way that such a way that tail of tail of tail of B coincide with head of vector A, then a vector connecting connecting from tail of vector A to head of vector B will be resultant vector, or we can also tell that two sides representing two vector A and B. So third side of triangle will represent resultant vector in opposite order. Okay, draw a triangle using vector A and B as a side of a triangle in such a way that tail of B coincide with head of vector A. So here, using this concept, we will draw here tail of vector B. So vector B is like this. So this is vector B. This is vector B. Okay. So tail of vector B should coincide with head of vector A. So I can write here this is vector A. Then then a vector connecting from tail of vector A to head of vector B. So tail of vector A to head of vector B, that means this one, will represent here a resultant, that is equal to A plus B. So this is triangle law. Triangle law means we have to construct a triangle, but we have to take care that vector A and vector B will draw in such a way that head of vector A should coincide tail of vector B. Then whatever is gap between initial and final point means tail of vector A, initial vector, and head of vector B, final vector, connecting vector between tail of vector A to head of vector B will represent resultant value. Okay, so this is resultant value. Here if this is theta, then this theta will be this angle. Extend this A, and this theta is angle between vector A and B. So this is angle between vector A and B. Okay, so this is angle between vector A and B. So this is how triangle law of vector addition. Second one is parallelogram law of vector addition. Then we'll learn about analytical method, means formula to calculate resultant of two vectors. Okay, so next one, parallelogram law of vector addition. Parallelogram law of vector addition. Parallelogram law of vector addition. In this law, we will construct a polygon using side of a vector. So here construct of parallelogram using vector A and vector B as a side of parallelogram, using side of a parallelogram, then then a vector connecting, this vector is a diagonal vector, we can say. Okay, so this is a diagonal vector connecting, then diagonal vector connecting common tail to common head will be a resultant vector. So a vector which connecting common tail to common head will represent resultant vector. Okay, so here we can draw this diagram. This is vector A and this is vector B. So vector A and vector B we can draw like this. Let's take here, this is vector A. Now vector B, another side, vector B, angle between vector A and B is theta. Now we have to construct a parallelogram. So this will be shifted here. Parallel shifting vector will not change. So we can shift vector B here. This is also vector B. This vector A we can shift here. So again parallel shifting vector, we know that if a vector is parallel shifted, magnitude of vector is not changing. Okay, and direction also not changing. So we can say vector is also not changing. Okay, so this is vector A. Now we have constructed a polygon parallelogram using side of a vector, using a vector as a side of this parallelogram. Okay, so which one is resultant? Connecting diagonal vector connecting common tail to common head. So of course there are two diagonal, this one and this one. So common tail is this one. This is not common tail. Head of vector B coinciding with tail of vector A. So this point is not common tail. So a vector connecting common tail to common head, this will represent a resultant vector. This value will be vector A plus vector B. Clear? So this is resultant vector. So this is using polygon law, parallelogram law of vector addition. Means this diagonal will represent resultant vector, but this diagonal must be connecting between common head to common tail. Okay, and it will be towards common head, common tail to common head. So this is resultant vector. Okay, so now we are going to find out a resultant value. Okay, analytical method to find out resultant of two vector. Okay, so next one, analytical or it is also known as mathematical method to find out resultant of two vectors. So resultant of two vectors. Okay, so here I will use triangle law, okay, to find out resultant of two vector. We can use that one also, but better I'm using only triangle. Okay, so this is a vector A and B. So for this situation only I will find out resultant. Okay, so let me take here, this is side A. So magnitude of this vector is, I will write A. Okay, this is vector, this is basically vector B. So I will draw here, but I'm not going to draw here. Why? Because I want to find out resultant. So if I'm shifting this vector from this using triangular, this is vector A, this is vector B. So vector B was actually acting at a point here. So we have shifted here vector B. So we have not changed vector value, direction as well as magnitude we have not changed. That means we have not changed vector value. So we can write here this vector b. Okay, so this is vector b, and magnitude of this vector b I can write b. So magnitude and direction. Okay, so if I'm connecting here, so of course this will represent a resultant value. This is representing a resultant value vector r, that is of course equal to a plus b. So now I have to find out magnitude of this one. So let me extend this one in this direction. This angle is theta. Okay, because that angle is only angle between vector a and vector b. Okay, so I will construct here. This is perpendicular drop from this point. So let's give some name. Okay, so this point I am saying a, this point I am saying, let me take this one o. Okay, so this point I am saying o, this point I am saying a, this point I am saying b, this point I am saying c. So this is perpendicular drop. Okay, so here this is b, from a to b, this value is b. So what is value of this one? This value will be b cos theta, means ab cos theta is ac. So ab cos theta is ac, but ab value is b. So b cos theta we can write here. Okay, what is value of this one? This one. So this is AB sin theta. AB sin theta equal to BC. So AB is B here. So we can write here this value B sin theta. This is B value. Okay. This is CB value, CB or BC. Okay. So B sin theta, B cos theta. So if I want to find out, this is O. If I want to find out from this point to this point, so I can write here, this is A plus B cos theta equal to up to O to C. Okay. So here in this diagram, we have calculated OC equal to A plus B cos theta, BC equal to B sin theta. So we can write here in right angle triangle OBC. This is right angle triangle OBC. We can write hypotenuse OB square equal to perpendicular BC square plus base OC square. Okay, so we can write here this one. So if I am writing resultant, that OB is O to B is nothing but a resultant. So resultant value I am writing R square, that is equal to BC. BC is B sin theta plus OC. O to C. So this O to C is A plus B cos theta square. Okay, so we can write like this. Now we have to simplify it. Okay, so to simplify it, I'm writing here. So this resultant value we can write here R square equal to B square sin square theta plus A plus B cos theta whole square. So we can write A square B square cos square theta plus 2AB cos theta. Okay, so this one and this one, if I'm adding, so in both there is B square. So take B square common, sin square theta plus cos square theta plus A square plus 2AB cos theta. So we can write here, this is equal to 1. So we can write here A square plus B square plus 2AB cos theta. So this is value of r square. So r will be equal to this one. So we can get resultant value using this formula, a square plus b square plus 2ab cos theta. Okay, where a is magnitude of one vector, b is magnitude of another vector, theta is angle between two vector. Okay, so here this theta is angle between two vector, two angle between a and b. Okay, so this is how we can find out resultant. But we know that this resultant is a vector quantity because we are adding two vector. So resultant will be also a vector. So we have to find out direction also. Okay, magnitude is given by this one, but direction, this is resultant direction. So we can assume here this direction is, let's take alpha from vector A. Okay, in anti-clockwise direction. So from that diagram, 10 alpha we can write for direction which is alpha is angle. So this alpha, 10 alpha we can write. What is 10 alpha from diagram? 10 alpha we can write here perpendicular BC upon base, that is OC. BC equal to B sin theta upon OC equal to A plus B cos theta. So we can write here this alpha will be equal to 10 inverse B sin theta upon A plus B cos theta. Okay, so this is value of alpha. Okay, so this is value of alpha. Alpha is, we can also write, this is angle between vector r and vector a, or we can say this much angle from a vector a in anti-clockwise direction. But better, this one is better term, always true. Okay, so angle between vector r and vector a, not angle between vector r and vector b. So this alpha is angle between vector r and vector a. Okay, so value and direction we can find out like this. Okay, so now we will see some special cases. Okay, so special cases here, special cases we will take here. First case, when theta will be equal to 0, means parallel, both are parallel vector, a and b are parallel vector, theta 0. Okay, then what would be resultant? Then if I am putting in resultant cos theta, cos 0, this will be 1, then it will convert into, a square plus b square plus 2ab cos 0, and this value will be a square plus b square cos 0 1, so 2ab, and this value will convert into a plus b whole square under root. So we can write a plus b. So when both are in same direction, means this is vector a, this is vector b, both are in same direction, then we can write resultant a plus b. Okay, what would be alpha? Alpha will be, if I put here theta 0, this whole will be 0, so alpha will be also 0. In this case alpha will be also 0, alpha representing direction. That means resultant will be in same direction. This is resultant. Resultant will be also in same direction. Okay, direction of a and b. Second case, if I am taking here when theta equal to 180, okay, that means vector a anti-parallel vector b, both are opposite. So let's take here, this is vector a, this is vector b. So we can write here resultant vector is this one resultant vector. Okay, this is resultant vector difference. So here if I am putting this value theta equal to 180, because in this situation theta 180. So if I'm putting here, so resultant I will get a square plus b square plus 2ab cos 180. If I calculate this value, so cos 80, 180 minus 1, so it will be a square plus b square minus 2ab, that is equal to a minus b. So this I am getting a minus b. So this is how. Now what would be alpha here? If a greater, if a greater than b, then alpha will be 0. If b greater than a, then alpha will be 1. Okay, that means whichever force will be greater, whichever vector will be greater, in that direction resultant direction will be. Clear? So this is second case. Third case is, third case is when theta equal to 90 degree. Okay, that means a vector perpendicular to vector b. Okay, so here if I am drawing it, so this is vector a, this is vector b. Okay, so resultant will be something like this. This will be resultant direction. Okay, so this is resultant direction. So this vector b I can shift here, means vector b, if I am shifting here vector, sorry, this vector b, if I am shifting here, so this is vector b, so here I have to connect it, so this will be a resultant vector. Okay, so here resultant, if I am calculating by formula, so this is a square plus b square plus 2ab. What is value of angle? 90. So we know that cos 90 is 0, so this value will be a square plus b square, and this will be 0. So simply it will convert r equal to a square plus b square, and this is root. So this is how we get resultant of two vectors which are mutually perpendicular. Okay, so perpendicular means both vectors are perpendicular. So in this case we have to find out this direction alpha. So tan alpha will be equal to, we can put here in formula also, tan alpha equal to b sin 90, that is upon a plus b cos 90, cos 90 0, sin 91. So we will get here b upon a, and from diagram also we can see this is b, this is a, so b upon a is tan alpha. So alpha will be equal to tan inverse b upon a. So these are three special cases when angle is 0, both parallel, so resultant will be summation of both vector. If theta 180 anti-parallel, then resultant will be subtraction of both vector. Okay, when theta is 90, then resultant is under root square summation, and resultant direction will be given by this formula. So here one conclusion we can say that maximum and minimum value of resultant will lie in between. When theta 0, then we'll get maximum resultant. So theta r will be always lesser than a plus b. Maximum resultant is when theta 0, and when theta 180, so we are getting a minus b. So this is a minus b. Okay, minimum value. But if b is greater, then what we will do? B is greater than, this will be b minus a. So better I am putting one mod here. So this range of resultant, this one is resultant, resultant. So resultant will always lie in between mod a minus b to a plus b, magnitude of a plus b. Okay, if a greater, then it will lie in between a minus b to a plus b. Okay, so this is all about concept, analytical method. This is very important formula. Okay, always we'll see that resultant of two vector we will calculate using this formula. Okay, so we have to remember this formula and this direction, okay, in which direction this resultant is acting. So this is all about addition of two vector. So in next lecture we will cover questions based on it. Okay, there are so many questions, so we will select few important questions which are most popular. Okay, so thank you so much.